Alright, so we're in section 7.3 and we're talking about surface area and volume of pyramids. So the first thing we need to do is come up with a description, a definition really, of what makes up a pyramid. We talked about prisms. We know that prisms have congruent parallel bases. Their bases are polygons. The sides of the prisms are parallelograms or rectangles. So we know all kinds of things about prisms. We want to figure out the same kinds of things about pyramids. So we know that a pyramid is a three-dimensional shape. What was our fancy word for three-dimensional shapes that we've been talking about? Can you help us out, Anna? What was our word that we said describes three-dimensional shapes? A polygon is a flat shape. Polyhedron, there we go. So a pyramid is a polyhedron. So we know it's made up, all the parts of it are polygons. A polyhedron with, and the important things about pyramids are it has a base, that's a polygon. And pyramids only have one base, so that makes them a little easier to work with in some ways. So a base that is a polygon, and three or more sides and the fancy word for sides are lateral faces. That are triangles. So we have a polygon for a base, and we have three or more sides. So if our base is a triangle, we have three sides, and then we go up from there. Three or more sides that are triangles. And just like prisms, we name pyramids by the shape of their base. So we have square pyramids, we have triangular pyramids, we have rectangular pyramids. So we name them by the shape of their base. There are some other parts, other words that we use for our pyramids. I want to draw a picture and label the picture rather than writing it all down. To draw a pyramid, what I usually do is start out with the base. So we'll make our base for this pyramid a rectangle. And then I'm just going to draw a dot up here. And then just connect the corners to the dot. And we'll have a nice pyramid. So there's my pyramid. So this would be a rectangular pyramid, I guess, or a square pyramid if the base were a square. So this shape is our base. The triangles are our sides or lateral faces. Lateral just means side. The tip of the pyramid is the vertex. This edge down here at the base is called the base edge. And this edge on the side is called a lateral edge.
What's the corner of the base called?
You could call it a base vertex, I guess. don't use that one a lot, but we could call it a base vertex, I guess. But the tip where all the triangles meet is the vertex of the pyramid. So we talk about the vertex, we're talking about this point at the very top. So any questions on the parts of our pyramid? So we have a polygon for a base, the sides, 3 or more that are triangles, and we name it by the shape of the base. Our pyramids get a little more complicated because we have 2 different heights that we have to deal with. So let's talk about the height of a pyramid. And we'll draw another pyramid. And we have 2 heights that we have to deal with here. So we'll draw a rectangular pyramid again. So there's my base. Connect my corners of the base to the vertex there. All right. So I'm going to draw in 2 different segments here. I'm going to draw one from the vertex down to the base. And we're making a 90-degree angle here. This red one we're going to call the height or the altitude. And I'm going to draw in one more in blue. And this one's going to go from the vertex rather than into the base to the edge of the base. And we make a 90-degree angle here. And this blue one we're going to call the slant height. Yes?
Wouldn't the slant height be the same as the lateral height?
So the slant height goes to the middle of the base, not to the corner. So let's write in what we're saying here. The height makes a 90-degree angle with the base, and it goes to the vertex. So you can kind of think of the height as kind of going up the middle of the pyramid. And we'll talk a little bit more about that in just a second. The slant height goes at a 90-degree angle to the base edge. Up the middle of the side to the vertex. So our slant height goes along the side of the pyramid. So we're going right along the middle here, and we make a 90-degree angle at the base edge. And the height goes from the base to the vertex, and we can kind of think of it going up through the middle. But that doesn't necessarily always work, because if I have a slanted pyramid, an oblique pyramid, so if my pyramid looks like this, my height would be outside the pyramid. So the height we can find the height outside the pyramid, just like we could find it outside a triangle or outside a parallelogram. So if my pyramid is slanted, the height doesn't necessarily go through the middle of the pyramid. It has to make a 90-degree angle with where the plane is sitting, or where the base is sitting. So we have two heights to keep track of with a pyramid. The slant height that goes along the edge or along the side, and the height that goes from the base to the vertex. All right, one last piece of information and then we'll be ready for our formulas. A regular pyramid. What would you guess we mean when we say a pyramid is regular? So it has, Evangelique says, has something to do with the sides being the same. But so when we said a shape was regular, what were we talking about? What did we mean about that shape? So Evangelique says the sides are the same. If we had a regular polygon, when we were talking about regular polygon, what did that mean, Jonas? Just a regular polygon. What did it mean about a polygon? Well, it has something to do with the sides, right? So if our polygon is regular, what do we know about the sides? Think of a square. A square is a regular polygon. What do we know about the sides? They're all the same. Okay. What about the angles? All the same. Okay, so if we have a regular polygon, then all the sides and angles are the same. Regular pyramid has a regular polygon as a base. So all the sides of our base are the same length. When we have a regular polygon as a base, the sides, or the lateral faces, sides are congruent, they're all the same. And they're all isosceles triangles. So when we have a regular polygon, or a regular pyramid, we have a regular polygon as a base. That makes the sides all congruent isosceles triangles. And the height then hits the center of the base. When we have a regular pyramid, our base is a regular polygon, a square, an equilateral triangle, a regular hexagon, something like that. The sides then are all congruent triangles, and the height will hit right at the center of the base. All right, now we're ready for our formula, finally. We have all the parts that we need. Any questions on the description or what makes up a pyramid? Okay. Our surface area formula. And this surface area formula is for a regular pyramid. Our surface area will say SA equals LP divided by 2 plus B. L is the slant height. P is the perimeter of the base. And capital B is the area of the base. And our units are going to be units squared. Now tomorrow we'll talk a little bit more about where the formula comes from, kind of like we did with prisms. For today, I just want to get you the formulas. You get a little practice using them, and then tomorrow I'll talk about where they come from a little bit more. So questions on our formula. So again, like I said before, we're going to have a different set of formulas for every shape. And each one is just a little bit different. So it's going to be important to remember what the parts are and to know a little bit about them. All right, let's look at an example using this formula. We want the surface area. Of a square pyramid. Now before I go further, square pyramid is telling me what shape is a square, Tanner? Yeah, so what part of the pyramid is a square? The base. So this is telling us that our base is a square. So we have a square pyramid, our base is a square with slant height. Of 5 centimeters and base side length of 6 centimeters. So this is our problem. We want the surface area of this pyramid. If the problem doesn't give you a picture, it can be helpful to draw a picture. So let me draw a picture. Here's my base. And it doesn't have to be perfect and beautiful, just a quick sketch to help you out. There's my base. The base is a square. There's my pyramid. It says the base side is 6 centimeters. So where is 6 centimeters going to go? Madison? So the base is what shape? Square, and it says the base side is 6 centimeters. So where is that 6 centimeters going to go? On the side of the square, right? So that's going to be 6 centimeters here. So that side is 6 centimeters. It says the slant height is 5 centimeters. So where do I draw my slant height, Preston? Where does our slant height go? We start at the vertex. Straight down the middle. Go ahead. To the middle of the base? Does the slant height go to the middle of the base? Angelique? It goes down the lateral face or the side. So our slant height is going to go down the side like so, and it makes a 90-degree angle at the edge of the base. So that side is 5 centimeters, that blue segment. All right, so the height of the triangle goes to the middle of the base. The slant height goes down the side. Our surface area, our formula, is LP divided by 2 plus B. We need a little bit more information. Let's find our area of our base. How do we find the area of our base? 6 times 6. The base is a square, so area of the base is 6 times 6, and I get 36. What's the perimeter of the base? How are we going to find the perimeter? 6 times 4. We have our side is a square, or our base is a square. We have 4 sides. Each one is 6. So perimeter of the base is 6 times 4 plus 24. I'm going to plug that into my formula. The surface area, and I forgot we wrote SA for surface area. SA, slant height is 5 times the perimeter of the base times 24 divided by 2 plus the area of the base, 36. Now, one important thing to remember about calculating with this formula. Do this part separate, do that part separate, and then add them together. So this, the dividing by 2, this part, all has to stay separate from this part. You add everything together at the end. So 5 times 24 is, should be 120, and we divide by 2, so 5 times 24 divided by 2 gives me 60, plus 36, and finally I get 96, and this should be centimeters here, 96 centimeters squared for my surface area. Questions on that example? And again, tomorrow I'll talk a little bit more about where this formula comes from, why it works the way it does. But for today, we'll just do a little practice calculating. And again, just a couple things to emphasize. The dividing by 2 only goes with this first part. It doesn't go with the whole thing. It only goes with this first part. Calculate this first part, calculate the second part, and then add them together. All right, our volume formula now. And this volume formula is for any pyramid. And we're going to say the volume is, anybody want to guess how the volume of a pyramid compares to the volume of a prism? So our volume of a prism was just the area of the base times the height. Volume of a pyramid is going to be less. Anybody have a guess how much less space is inside a pyramid than a prism?
Divided by 2.
Divided by 2? Close? Close? Turns out it's divided by 3. So our volume of a pyramid is the area of the base times the height divided by 3. And we'll talk a little bit more about why that formula turns out the way it does tomorrow. So it's the volume of a pyramid is 1/3 the volume of a prism that has the same base and the same height. All right, let's look at an example of calculating with this one, and then we'll be done. So we have a square pyramid. So which part of the pyramid is a square, Nick? The base. Our base is a square. So we have a square pyramid. Our height is 112 feet. And our base side is 99 feet. So if I draw a quick picture here, we know we've decided our base is a square. So there's my square. There's my vertex. All right, so let's label our parts. It says the base side is 99 feet. So where are we going to put our 99 feet, Melissa? Our base side is 99 feet. Along the side of the base. So this is going to be 99 feet here. We're not going to put it up along the side or something. The base side is 99 feet. And our height, it says our height is 112 feet. So where does our height of our pyramid go, Jorge? Start at the vertex for our height and go where? Right off the base. Perfect. So our height goes down like so. If I had drawn my picture perfectly, this would go right to the center. So our height, and we make a 90-degree angle. So that blue segment is 112 feet. So that would be a picture of my pyramid and the problem. So our volume is the area of the base times the height divided by 3. How are we going to find the area of the base? Zoe? 99 times 99, length times width of our base. So we get 99 times 99 turns out to be 9801. And our height we know is 112, so plug those numbers in. So we get 9801 times 112 divided by 3. I put that in my calculator and I calculate, and it turns out that this pyramid has a volume of 365,904 cubic feet. 365,904 cubic feet for the volume of this pyramid. Questions on that example? All right, so the place where we make common mistakes. One, confusing the height and the slant height. Two, figuring out the base side, making sure you get the length that they give you for the base side on the side of the base. And the other big place where we make mistakes with pyramids, where students make mistakes, is trying to combine this all together when they calculate. Calculate this part, calculate that part, and then add them together. We'll talk more tomorrow about the formulas and where they come from. Today's homework problems are just, they're pretty easy homework problems just using these formulas. Tomorrow we'll talk about this a little more, and we'll do a couple more complicated problems. All right.